This is the problem taken from Jungle Book, problem number 372. The 280 kilogram, 6 meter wide rectangular gate shown here is hinged at B and leans against the floor at A, making an angle of 45 degrees with the horizontal. The gate is to be opened from its lower edge by applying a normal force at its center. Determine the minimum force F required to open the water gate. Let's focus on this figure. We are asked to calculate the minimum force F that will allow the gate to open. Open in this case means it starts to rotate about point B. Before we calculate F, what we need to do is to calculate whatever forces that present against this gate. Okay, for that, we start by drawing the free body diagram. So let's isolate the gate. So this is the gate AB. I maintain the water surface and the floor for references. Okay, now, the first thing that we have is the weight of the gate. We know that the gate has a rectangular shape. So when we have a rectangular shape, the centroid will be right in the middle. In the case of 2D, of course, it is there in the middle. So from this centroid, if we assume that the material of the gate is uniform, so assume the gate is uniform, in that case, the center of gravity will have the same location with the centroid. The weight coming from the center of gravity. So in this case, the weight, since we have the assumption that the gate is uniform and the CG is the same as the centroid, so the weight will start from the centroid. The value from the problem is stated 280 kilogram, which means 2,746.8 Newton. I just multiply with G. So this is the weight. Now let's see the reaction force. Start with A. At A, the floor blocked the gate to move downward. It doesn't block the gate to move left and right, but it cannot move downward. In that case, the reaction will be vertically upward. At B, the hinge doesn't allow the gate to move to the left, right, horizontally, or vertically. So it means the reaction force will be horizontal and vertical. Here I choose right and upward. You can choose left and downward. It's up to you. That's just the convention. If we assume that no friction at the hinge, so that the gate can swing freely about B, so there will be no reaction moment. Now let's find out the force produced by the water on this left side. For that, we are going to extend the surface of the gate until it reaches the water surface. Let's say the intersection is O. From O, we draw a right triangle. So this right triangle representing the pressure distribution. Pressure distribution only valid from A to B only. So I draw the pressure distribution on the gate AB. From here, we can calculate the resultant force, Fr. The Fr applied at point B, center of pressure. The Fr itself, we call it resultant force or total pressure. If we assume that the atmospheric pressure acts in every part of the gate, left and right, so that it cancels each other, in that case, can ignore that atmospheric pressure. So we deal with gauge pressure only. So from the previous class lecture, we have this equation to calculate Fr. So it's either this one, or this one, or any, depending what do you have the most. One more thing. The question is about the minimum value of F so that the gates start to open or the gates start to rotate. When we increase the value of F, the gates start to rotate or this contact start to lose the reaction force at AY at A will be 0. So we don't need to consider AY anymore because we are talking about the gate when it starts to open. Here we have the weight and then we have the equation to calculate FR. So having this one to calculate F, of course, later we are going to apply the static equilibrium equation. In that case, we are going to use the equilibrium of moment about point B. Before that, let's try to find the value of FR using this equation. So let's see. So this is the equation. See what we have. Rho, we are dealing with water. We assume that the density of water is 1,000 kilogram per meter cube. G, you know, is 9.81 meter per second square. YC is the distance from C to point O, to the water surface, the inclined distance. Or maybe you want to have HC. HC is the vertical distance from C to the water surface. So this one is vertical, this one is inclined. We know the relation that AC is YC sine theta. AC is YC sine theta. Theta, of course, is the angle formed by the gate with the horizontal. In this case, we have 45 degrees. Either this one, 45 degrees, or that one is the same thing. Yeah? AC can be obtained by observing this dimension given. You know that C is in the middle of the gate. Yeah. So it means from B to C vertically, it will be 1.53 over 2. To the water surface will be 1.5 plus 0.5, 2 meters. So AC here will be 2 meters. Now let's calculate the area. We know that the triangle, the gate has a rectangular shape. So this is just to illustrate that. According to the problem, the width of the gate is 6 meters. The length, knowing that the vertical measurement here 3 meters from the floor to B, angle 45, so we can have the length of AB, which is 3 over sine 45 degrees equals to 4.24 meter. Okay, having that, we can calculate the area. Area equal to 25.6 meters square. So now, I think we have everything. So we put everything inside this equation. We obtain the value of the resultant force, Fr, which is equals to 502.3 kilonewton. What we observe here is that this value is much bigger than the weight of the gate. This one 502, this one 2.7 kilonewton. Now, we need to find where this resultant force is applied, which is point P. From the class as well, the previous lecture, we have the equation. You can calculate YP here, that is the inclined distance from point P to point O, or you may want to calculate HP. HP again is the vertical distance from P to the water surface. The relation between HP and YP, of course, HP equal to YP sine theta. Now let's see the moment of inertia here. It is written IXXC. IXX means the moment of inertia about the axis XX passing through point C. So according to our lecture, for this case, IXX passing through C is AB cubed over 12. So for our case, the A will be 6 and the B will be 4.24 meters. You obtain the moment of inertia of the gate about axis X passing through point C is 38.11 meter in the power of 4. To calculate YC, we know AC. AC is previously, AC is 2 meters. So we know that AC is YC sine theta So you can calculate YC, AC over sine theta, it is 2.83 meters. So we see this equation, we have YC, we have IXXC, we have the area, we have YC. So we have everything for this equation. So we can calculate. We obtain YP equal to 3.36 meter. So that again, YP is the distance from point P to point O. Finally, we need to calculate F. So to calculate F, as planned, we are going to apply the equilibrium, or precisely, the equilibrium of moment. We choose point B. Why we choose point B? It allows me not to calculate Bx and By. We know that moment is distance times force. If the distance equal to 0, the moment will be 0. So if I choose B, I don't need to calculate Bx and By. I take the convention positive anticlockwise. So if we write the equation of moment for this diagram, we have W, which is the weight, times the right distance. The right distance means, in this case, is BC cos 45 degrees. The moment, due to the weight, it will be creating anticlockwise moment. So in that case, this one is positive. The FR will create also anticlockwise about point B. So it is also positive. The distance from FR to B is BP. And then the last force is this F. When the F is applied, it will create clockwise moment. And the distance is BC. So this is the equation. Now let's see one by one. BC cos 45, we have an angle 45. It means cosine equal to sine. BC cos 45, if we see this triangle, BC cos 45 is this one. And BC sine 45 is that one. And we know that this one is 3 over 2. So BC cos 45 is 1.5. Knowing BC cos 45, we can calculate BC, which is the length from C to B. So we have BC equal to 2.12 meters. BP, for BP, we see this triangle, this bigger triangle passing through BP and this right angle. Okay, BP is the distance from B to P. What we have calculated previously is YP. YP is from O to P. What we need is B to P. So it means BP is Y minus OB. YP has been calculated. OB, you see this one. OB is from O to B. So we know this vertical distance, that is 0.5. So having 0.5, having 45 degrees, you can calculate BP. That is 2.65 meters. Having that, we can put all these values inside this equation. The only thing remains is F. So you can calculate F. We obtain F equal to 629.72 kilonewton. Again, we notice that this value is much bigger than the weight, which means that the force that you need to work here, to apply here, is mainly to work against the water pressure force. Okay, with that, we answer this problem.